So again I'm back. Good morning to all of you. This time I will be taking the topic on basics of earthing. So basics of earthing is also a very important topic along according to your exam point of view, and it will be also included in a broad topic of distribution system, or you can say in the substation part only. So moving ahead, discussing the contents of this particular topic is it will be covering the introduction of the earthing system, basic definitions, electrical properties of ground and earthing system, the types of earthing system that we all are using, and the testing of earthing system, that if we are having any system we have to test it also. So what all means or what all methods are available for testing of a particular earthing system, and finally we will be concluding. But I will be floating two videos on this particular topic. So today I will be discussing 10 types of earthing system, and in the next video I will be discussing on testing of earthing system. Okay, so starting with the introduction part, so we have to discuss that what is the basic meaning of earthing system. As you can see in a particular slide or particular screen, that earthing system is nothing but the earthing which is a total set of measures used to connect an electrically conductive part to the earth. We are doing nothing, we are connecting and some conductive part of any instrument with the earth, so that if there is any amount of fault or if there is any amount of short circuit, high value of current is flowing, so it will be purely taking the part to the earth, so that if earthing is not there, if earthing will not be there, and by anyhow you are touching that particular, or anyone or any human being is touching that particular system, he or she may get a shock. So to reduce that, we have to have a proper earthing system in our particular at our domestic level also, and at our industrial level too. But the basic main question is that is somewhere we are saying that it is earthing, and somewhere we are saying it is grounding. So the reason for it is already mentioned in this particular slide, is that the whole of the world may be considered as a vast conductor which is at a reference zero potential. But in the UK, in United Kingdoms, we used to refer to this as a earth, while in USA, in United States of America, it is called as ground. So USA used to call earthing system as a grounding system, and over here the UK and the Europeans and the Asian, we are dealing it as a, you can say, earthing system. The earthing and grounding system both are equal, both are same, but it is two different terminologies which is being used, one by the UK standards and one by the USA standards. But here we will be following the British or nothing but the UK standards for calling it as a earth. Okay, so moving ahead, what will be the again we are discussing nothing but the continuous of the introduction part only. We have already said that it is nothing but in UK we are saying it as earth and we are saying USA as ground. But what will be the overall picture of a particular, you can say, a grounding system? So here in this circuit diagram you can see that in the primary end you are having a transformer, in the secondary end you are having some exposed conducive part. Some exposed conducive part is nothing but the instrument that you are having. That body of that instrument is connected to a ground. You can see that body of the instrument is connected with a ground. Okay, so as it is connected with a ground, so we can say if there is any amount of short circuit, there will be a flow of fault current. You can say that there is written path for the earth fault current. So that path for the earth fault current will be taking the path of that exposed conducive part, and now it will not going inside that exclusive conducive part and returning back it to the transformer. It will going to take the path of that extra wire which is connected with the earth, which is connecting between the earth and the surface of that instrument. So it will going to take that path, and it will going to return back by taking the return path of your ground. So it will going to take the return path of your ground. It will be only and only possible if you are having a good conductive system, or if you are having a good conductive and earthing system available for that particular location. If earthing is not available, it will not going to take that path, because at that time the resistance will be very high and current will not be allowed to flow. So there should be a proper earthing available, so to reduce a shock hazard existing at that point of time. Okay, discussing much more on the earthing. So there will be some advantages and some disadvantages of earthing. There's advantage, we all know that whole of the electrical system is tied to the potential of the general mass of the earth and cannot float at another potential. So as we know, the meaning of this line is that all the instruments are working on different potentials, but it should be referenced at a common value. Then and then only it will be connected. We cannot have that one, let's suppose the live conductor is at 220 volts. It's okay that instrument will be taking 220 volts, but it cannot be referenced at 10 volts. Somehow another instrument is referenced as 20 volts. Somehow another instrument is referenced at 30 volts. So that referencing will be different, the amount of current will be different, and the designing of the protection system will be very tough. So for that, the reference should be same to all. So there will be a common point, there will be a common reference point available. That common reference point will be nothing but the ground potential. We always know that ground will be at 0 degrees, 0 volt. The ground will be at 0 volts. At the ground will be at 0 volts. So we will be taking ground as a common reference point, connecting all the general mass of earth. All the general instruments will be having a common reference point as earth only. We cannot float at another potential. We cannot float at different potential for different instruments. It will not be a good way to proceed. Okay, so by doing earthing, we will be keeping all the potential at 0 potential only, at 0 volt only. So that will be the advantage of earthing. The second is, by connecting earth to metal work not intended to carry current, an extraneous conducive part or an exposed conducive part, by using a protective conductive path is provided for fault current which can be detected in, if necessary, broken. So that protective wire that is connected with the surface, that is connected in between the surface of a particular equipment with the ground, will not going to take the current in the healthy position. Going back to that diagram only, you can see that this wire which is being connected, with the surface of that particular system, particular conducive part, will not going to take the current in the healthy position. It will going to take the current only and only when the fault current will going to come, because at the time of fault current, that resistance will be treated as very minimum, so it will going to take the minimum resistance part. But at the time of normal current, it will not be allowing to flow that current, because at that time it will be offering high amount of resistance. So it should be designed in such a manner that earthing will going to come into picture only and only when there is a high amount of current is flowing, or there is a fault path available. Okay, so these two are the advantages of earthing. On the right hand side, you can see the most disadvantage that we are discussing in electrical engineering is nothing but the cost. The provision of complete system of protective conductors, earth electrodes, etc. will be very, very expensive. But at the cost of expense, we are getting a good amount of protection also from that. So we will not be thinking much on the cost. We will be thinking that it will be giving the protection to the equipment also, and it will be giving the protection to the working personnel also. Okay, so the single most disadvantage of the earthing will be the cost. Moving ahead, that we have to discuss the basic definitions. These definitions you should be remembering. It is a standard definition, so it should be written in a particular manner that is being given in this particular screen or a slide. What is the first term? That is the earthing conductor. It is a conductor which connects a part of an electrical installation, exposed conducive parts or extraneous conducive part, to an earth electrode, or which interconnects the earth electrodes. So that earthing conductor is nothing but the conductor that we will be using in between the earth electrode and the surface of a particular instrument. So that conductor is known as earthing conductor, because that conductor will be responsible for connecting your outer surface or the surface of a particular instrument to the earth electrodes, which is being digged inside the earth, okay. The second is the reference earth. Reference earth we have already discussed. It is nothing but the common potential that we are talking about. So reference will be the earth, that is the part of a ground particularly on the earth's surface. It is any other part of a ground which will be considered for a particular grounding, where your ground electrodes will be digged, where we will be having the earth electrodes, and that portion will be treated as a reference earth. Next will be the earthing voltage. Now this is important. What is earthing voltage? It is the voltage occurring between the earthing system and the reference earth at a given value of the earth. Current flowing through this earthing system. तो अगर at a given value when the current is flowing through that earthing system, the potential between the system and the reference earth will be at zero potential, and the particular amount of current is flowing through that particular conductor. So that difference of two voltages will going to give you the earthing voltage or the earthing potential, because we always know that the ground potential will be at 0 volts, but as soon as current is flowing through that earthing rod, it will be developing certain potential. So difference between that potential with the ground is known as earthing voltage or earthing potential. Next is nothing but the earth resistivity. Earth resistivity is nothing but the specific earth resistance only. It is the resistance measured between two opposite phases of 1 meter cube of earth. The earth resistivity is expressed in ohm meter. Wrongly here written as figure 1. I have not attached any amount of figures, but you can assume that if you are having a 1 meter cube of earth, so the resistance measured on the two opposite phases will going to give you the particular earth resistivity, because you know that rho is nothing but R into A upon L. That R will going to get, as we are having a soil, so that soil resistance will be available. As we are assuming a 1 meter cube of earth, so it will be having a particular cross-sectional area by 6a square, and there will be a particular length of between two opposite faces. Let's suppose it is A. So the formula will be for the resistivity will be nothing but capital R, which will be known depending upon the structure of a soil, depending upon the homogeneity or heterogeneity of a particular soil. The cross-sectional area will be nothing but 6a square. A is the edges of a particular cube, and L will be also equal to A only. So the final formula for the soil resistivity will be nothing but 6 small a into capital R. 6 small a into capital R. Okay, that will be helpful for the calculation of earth resistivity. Okay, so the next coming is earth surface potential. In the earth surface potential is nothing but the difference of the voltage between a point X on the earth surface and the reference earth. So here we will not be taking the potential of that earthing rod. We are taking the potential at the earth only, but other than the reference earth. Reference earth we have taken that where we are digging and where we are putting the earthing rod, where we are assuming that a reference earth is kept at 0 volt, but some other distance x, if we are traveling a distance x meters from that earthing rod on the surface of the earth only. So let's suppose we reached at a certain point P. At point P, from point P to that earthing rod, that there will be a certain amount of distance. So that potential available at point P that will be available will be nothing but we can say is a earthing surface potential Vx. Okay, that is also very important when we will be discussing somewhat about the step potential and touch potential. So next will be the electrical properties of ground. This electrical properties of ground is a certain data only that you do not have to remember, but this data you can see that if you are having different types of ground, the average value of ground resistivity will going to change. if you are having the boggy ground, if you are having the adobe clay, if you are having a sand clay, if you are having a sand and sandy ground, peat type of ground is available, gravels if there is there. So as you can see, gravel is there, there will be the highest, or you can say upmost highest value of your resistivity. Stony and rocky ground will be also having the highest value of resistivity. So at that portion, that's why we always used to have gravels available in the substation, because it will be having high resistivity. So as it will be having high resistivity, the amount of current flowing at the surface of the will be very less, so it will be having the less chance of having a shock. That's why in substations we will be having gravels, because gravels, as you can see, the average value of ground resistivity will be nothing but 1000. Okay, in concrete you can see it is around 151 part of cement. Again, we will be discussing the next topic is electrical properties of earthing system. The electrical properties of earthing depend essentially on two parameters: the earthing resistance, configuration of the earth electrode. Earthing resistance, as it is written in the particular screen also, you can read that earthing resistance determines the relation between the earth voltage and the earth current value. The earth voltage that we have already discussed, that earth voltage is nothing but the earthing potential only, and depending upon that earthing potential, what is the amount of current flowing through that particular earthing rod is known as the earth current value. So the ratio of earthing voltage with the earth current value will going to give you the earthing resistance. The configuration of earthing electrode also determines the potential distribution on the earth surface. So what is the configuration of earth electrode means that if you are having a single rodded structure digged inside the ground, or if you are having a mat type structure, or if you are having a cage type structure, so depending upon the configuration of the earthing electrode also, the potential distribution is nothing but the earth surface potential Vx that we have discussed in the basic definitions on the earth surface will be also be changing by changing the configuration of a particular earth electrode. Okay, so both of these things will be responsible for the determination of electrical property of earthing system. One is earthing resistance and another is configuration of the earth electrode. Moving ahead in that, as we have already discussed that term of that two terms, that is of touch potential, step potential, that we have to discuss over here. The potential difference on an earth surface is an important consideration in assessing the degree of protection against electric shock, because we always know that how much potential is distributing, that potential difference will in a distribution will going to give us the value of soil resistivity, will going to give us the configuration of earth electrode. So hence, if we are having this amount of data, we can say that how much degree of protection we can give on a certain amount of electrical shock available, or you can say having that electrical shock. So it will going to determine two very much important terms, that is the touch potential and step potential. So first we are going to study the step potential word by word. It is written as when current is flowing from an overhead conductor through a chain link fence to the earth, a high voltage condition is created. That is correct. That I think that you are having no problem in this up till this word. And a voltage gradient will occur based on the resistivity of a soil, resulting in a potential difference, also known as potential difference between 2 points on a ground. This is called step potential, as it can cause voltage difference between a person feet. So now let's assume we are having that diagram also, picture view also. This just assume that you are the left man of your particular standing, which is not touching the earth, which is not touching the tower. Assume that you are that human being which is not touching the tower, which is standing left of the particular tower. As you are seeing the video, your left hand, in front of your left hand, the man is the person or the human being is standing, that you have to consider it to be you only. Let's suppose that there is a fault or induced voltage. Fault induced current is taking that red path, is taking the path of that chain like fence structure, and it is entering inside the ground. As you can see in the downward, that it is having high soil resistivity, so that current will going to enter inside that ground. You will be having the earthing, but as the resistivity of a soil will be changing, so the potential will be also changing. So if you are going very much nearer to that particular earthing tower, if you're not touching that earthing tower also, you can get a shock. How you can get a shock? You can see that in the left hand side human being, you can see as the current is going inside, it will going to take the path of the surface of the earth, and it will start entering into the body of a particular man, and depending upon the potential difference of its step. So if the steps will be very much nearer, the potential difference will be less. If the steps will be far, the potential difference will be more. Depending upon that, current will going to take the part of your body. So it is very important that if you are moving nearby in a particular tower station, you should be very cautious, because without touching the earthing tower, without touching the tower of a transmission line also, you can get a shock due to the step potential that is created between the two steps. That's why the name is given step potential, because it is created between two steps. Okay, moving back, we have to discuss the touch potential also. Again, we will be studying that word by word. Touch potential is the voltage between any 2 points on a person's body, hand to hand. It can be hand to hand, it can be shoulder to back, it can be elbow to hip, it can be hand to foot, and so on. For example, if an overhead conductor falls on a car and a person touches that car, current could pass from the energized car to the person, through the person to the ground. It is very simple. If that particular thing is energized, you are touching it, it will going to take the part of your body. So it is not much required to be explained, as you can again see in this picture view of step and touch potential. Now assume that you are the right hand side person, which is intentionally, I cannot say intentionally, by mistakenly you are touching the earth tower. As you are the electrical engineer, you can touch the earth tower, as you can touch the transmission line tower. As you are touching, as there is a fault, it will going to take the path of your body also, and at that point you will going to get a shock. So depending upon the resistance of a body, which we can say at the dry condition it is around 1000 ohms, in wet condition it can be less than 1000 ohms, or it can be around 500 or 600 or 700 ohms, because water is a good conductor of electricity. So it will going to depend upon the resistance of a body, and if you are by mistake you are touching the particular transmission line tower which is being energized due to the certain amount of fault, the fault current will going to take the part of your body. Okay, that is about the step and touch potential. Now we have to discuss the last topic for this particular lecture, for this particular video, is the types of earthing system. So there will be two types of earthing system. One will be simply as electrical earthing system, and another will be using at higher level, that is the industrial level earthing system. In electrical earthing system, it is simple that we have to remember that the overall earthing system for the electrical type of earthing system that we'll be using at the domestic level also will not be greater than, or should not be greater than 4 ohm. 4 ohm से ज़्यादा हम रेजिस्टेंस नहीं दे सकते. 4 ohm से हम ज़्यादा रेजिस्टेंस नहीं दे सकते फॉर इलेक्ट्रिकल टाइप ऑफ अर्थिंग सिस्टम. But in this earthing system, we will be using bare conductors for the earthing grid, and it will be buried directly underground. Each section of the underground grid will be acting as a individual earth. So the number of grots you are digging it, you are connecting it, you are increasing or decreasing the particular amount of resistance depending upon the grid connection, depending upon the earthing bare conductors grid connection. So it is a very simple type of earthing that will be used at the domestic level, and it will be, and I hope that it will be available at your home also, where we will be having the earth, which is important to have a earthing system also. But the important point to discuss is that the overall earthing resistance cannot be greater than 4 ohm, no matter which point of the grid is put under measurement. No matter which point of the grid is put under measurement, but the earthing resistance cannot be greater than 4 ohm. And what type of conductors we'll be using? We'll be using the bare conductor, which will be very highly conductive in nature, and it will be digged inside the ground, and it will be simply treated as a individual earth. The second type of, and the last point that we'll be discussing in this video, will be the instrument earthing system. In the instrument earthing system, as it is written in the particular screen, that it will be done in much more in the sophisticated manner, because here many costly electronic equipments will be dealt and it should be protected very cautiously. So basically we'll be having a matte type of grounding, and more highly, you can say, designed grounding will be using over here. But the range of earthing resistance that we'll be keeping over here is 1 ohm. Why 1 ohm? The lesser the resistance, so how large amount of current can flow through it, so it will not going to it will going to have a more protective structure as compared to domestic level. Because at the domestic level, at the earthing electrical earthing system that we have discussed in the previous slide, is having the range of 4 ohms, but here we are having the range of, we have constricted down the range from 4 ohm to 1 ohm. So we are increasing the protective level, because here we are, this instrument earthing system will be using at industrial level also. So in industrial installation also, as it is written in this particular slide, and it is also written that it is a it will be used for sophisticated power and electronic equipments. So protective measures should be taken to safeguard the instrumentations and relative control panels. So if anyhow control panel will going to fail, the reliability will not be there, the whole of the electrical supply will be shut down. So for that, the earthing resistance kept should not be greater than 1 ohm. It should be having the value of 1 ohm throughout the instrument earthing network. So this is the type of earthing system that you should know in the particular basics of earthing. In the next lecture, we'll be discussing the testing of a particular earthing system. For this video, this is the last topic that we have to discuss. Okay, thank you.